In this tutorial, we'll look at how ions are formed, the forces that hold the ions together, and how the structure of the ionic compound relates to its formula. The box contains two negatively charged ions. When I drag one towards the other is pushed away. Now let's look at how ions with opposite charges behave. When I drag a positive ion towards a negative ion, they're attracted until they touch each other. The oppositely charged ions attract each other. When they're close enough, they stick together. Let's see how we can use this idea to build ionic compounds. Number 1, opposite charges attract and stick together. Number 2, alike charges repel each other. In order to build an ionic compound that sticks together, you need opposite charges, both a positive and a negative ion. Answer the question for slide 5. The positive ion is formed from an atom that has a tendency to lose electrons. Since metal can easily lose electrons, the positive ion will usually be a metal. Atoms on the left side of the periodic table tend to form positive ions. The negative ion is formed from an atom that has a tendency to gain electrons. Since nonmetals form ions by gaining electrons, the negative ion will usually be a nonmetal. Answer your next question. Atoms on the right side of the periodic table tend to form negative ions. So far, we have learned the following. Number 1, metals form positive ions. Number 2, nonmetals form negative ions. Therefore, metals and nonmetals can bond together by forming an ionic bond. Let's take a closer look at how this process works. Let's choose sodium as the metal and chlorine as the nonmetal. Answer your next question. Chlorine atoms have a strong attraction for electrons. Under certain circumstances, the chlorine atom will be able to take one electron from the sodium atom. An electron is ripped from the sodium atom, turning it into a positively charged sodium ion. Answer your next question. The chlorine atom gains the electron and becomes a negatively charged ion called chloride. Answer your next question. The two atoms are now oppositely charged and are called ions. Since two ions have opposite charges, they are attracted to each other. Two ions are held together by the attraction between the opposite charges. This is called an ionic bond. Answer your next question. The process you just saw was simplification. Let's take a look at this again in a way that more closely resembles the way these atoms would interact in the real world. Chlorine is typically found as a gas whose atoms are in pairs. Sodium is typically a solid metal. When it's heated, it can vaporize, separating individual sodium atoms. Answer your next question. Each chlorine atom in the Cl2 molecule needs one sodium atom to interact with. Answer your next question. The end result is that each Na+ ion is bonded to a Cl- ion. Answer your next question. But remember that opposite charges attract. Watch what happens next. The positive ions will attract any negative ions around them, just as negative ions will attract any positive ions nearby. Many ion pairs will spontaneously self-assemble into an ion crystal. So each sodium is paired with one chlorine, but those different pairs start to group together in a really organized pattern, like this. Answer your next question. This continues in 3 dimensions until no more ion pairs are nearby. Okay, you can see me demonstrating a crystal below. So instead of calling this compound a molecule, we call it an ionic crystal. Answer your next question. Now let's take a look at how we write the formula for ionic compounds. In this crystal, I count 3 sodium ions and 3 chloride ions. Answer your next question. There's 1 sodium ion for every chloride ion. Since the crystal contains a 1-to-1 ratio, we write the formula as NaCl. All right, you've completed your assignment. Great work.